December 7, 1944 dawned cold and gray over the Ardennes forest as Obergefreiter Hans Müller adjusted his frozen fingers around his Panzerfaust. Watching the morning mist roll across the Belgian countryside, what he could not see, could never have imagined, was that less than 2 kilometers away, American tank crews were orchestrating the most sophisticated battlefield communication network the world had ever witnessed. The Sherman tanks rolling through the frost-covered fields carried a secret that would revolutionize warfare forever: the SCR 506 FM radio system. Inside the lead Sherman of the 3rd Armored Division, Staff Sergeant James "Jimmy" O'Brien pressed his headset closer to his ear, receiving crystal-clear transmissions from tanks spread across a 10-mile front. The frequency-modulated signals cut through static like a hot knife through butter, carrying tactical information with unprecedented clarity. While German panzer crews still relied on the archaic amplitude-modulated systems that crackled with interference and betrayed positions to enemy intercept units, American tankers enjoyed secure, jam-resistant communications that transformed armored warfare into a precisely coordinated symphony. The development of this revolutionary technology traced back to 1933, when American engineer Edwin Howard Armstrong first demonstrated frequency modulation at Columbia University. By 1942, the United States Army Signal Corps had recognized the profound tactical advantages of FM radio and began equipping Sherman tanks with the SCR 506 system. Each unit weighed only 35 pounds compared to the bulky German Fug 5 radio sets that occupied precious space and required multiple operators. Lieutenant Colonel William Wild Bill Richardson, commanding officer of the 2nd Battalion, understood the game-changing nature of his equipment better than most. As documented in the official 3rd Armored Division after-action reports, housed in the National Archives, Richardson's tanks could coordinate complex flanking maneuvers with the precision of a Swiss timepiece. German intelligence officers, monitoring American radio traffic, repeatedly expressed bewilderment at the Americans' ability to execute seemingly impossible tactical coordination. The psychological impact on German forces proved equally devastating. Panzer crews, accustomed to fighting semi-independent battles with minimal communication support, found themselves constantly outmaneuvered by Sherman formations that seemed to anticipate their every move. What they witnessed appeared almost supernatural: American tanks responding to threats before they fully materialized, converging on weak points with uncanny timing, and disappearing when German forces attempted to concentrate firepower. Technical Sergeant Robert Bob Martinez, the radio operator in O'Brien's crew, fine-tuned his equipment while monitoring multiple frequencies simultaneously. The SCR 506 allowed him to maintain contact with battalion headquarters, coordinate with adjacent units, and call for artillery support, all while remaining virtually undetectable to German intercept stations. The frequency hopping capability and narrow bandwidth signals made American transmissions nearly impossible to jam or triangulate. As the Battle of the Bulge intensified, this communication superiority would prove decisive in ways that German high command could never fully comprehend. The Wehrmacht's tactical doctrine, built around rigid command structures and inflexible communication protocols, proved no match for the fluid, responsive American system that turned individual tanks into nodes in a vast information network spanning entire army groups. January 15, 1943 marked a pivotal moment in military history as Major Edwin "Ed" Day Hawkins stepped into the sterile corridors of the Signal Corps Engineering Laboratories at Fort Monmouth, New Jersey. The brilliant communications engineer carried with him blueprints that would fundamentally alter the balance of World War II, though at the time, even he could not have predicted the profound impact his work would have on armored warfare. The project designation read simply SCRFI 106 Development Program, but the technology contained within those manila folders represented nothing less than a revolution in battlefield communications. Hawkins, a former Bell Telephone Laboratories researcher who had worked alongside the legendary Edwin Armstrong, understood frequency modulation theory better than perhaps any military officer in the world. His civilian background in commercial radio broadcasting proved invaluable as he adapted cutting-edge communication technologies for the brutal realities of tank warfare. Unlike the German engineers who remained wedded to amplitude modulation systems developed in the 1920s, Hawkins embraced the superior noise rejection and clarity that FM technology provided. the development challenges proved immense. Tank-mounted radios needed to withstand crushing vibrations, extreme temperature variations, and the electromagnetic interference generated by the Sherman's engines and electrical systems. Traditional vacuum tubes shattered under combat conditions, forcing Hawkins and his team to develop ruggedized components that could survive the punishment of armored warfare while maintaining crystal-clear communication quality. Working 18-hour days in converted warehouse laboratories, Hawkins' engineering team solved problems that had stymied military communications experts for decades. They miniaturized components without sacrificing performance, developed shock-resistant mounting systems, and created frequency allocation schemes that prevented the mutual interference that plagued earlier RADIO networks, according to Classified Signal Corps' technical reports declassified in 1978. The SCR-506 achieved communication ranges of up to 25 miles under optimal conditions, triple the effective range of comparable German systems. The testing phase revealed capabilities that exceeded even Hawkins' optimistic projections. At the Aberdeen Proving Ground in Maryland, prototype-equipped Sherman tanks demonstrated the ability to coordinate complex maneuvers across vast distances while maintaining perfect communicato in discipline. Tank commanders could whisper tactical instructions that reached their intended recipients with perfect clarity, while remaining completely undetectable to simulated enemy intercept stations positioned less than a mile away. Captain Margaret Maggie Thompson, one of the few female officers involved in the testing program, documented the psychological transformation she witnessed among participating tank crews. Soldiers who had previously operated in virtual isolation suddenly found themselves part of an interconnected web of information sharing. Tank commanders began thinking beyond their individual vehicles, spontaneously developing small unit tactics that leveraged their communication advantages to devastating effect. The production challenges proved equally daunting. American industrial capacity, already stretched to breaking points by wartime demands, had to accommodate the complex manufacturing requirements of frequent Y-modulated radio equipment. Hawkins worked closely with civilian contractors, adapting mass production techniques originally developed for commercial radio manufacturing to military specifications. The Motorola Corporation, leveraging their expertise in mobile communications, became the primary contractor for the SCR-506 production program. By late 1943, the first production models began rolling off assembly lines in Chicago and Philadelphia. Each radio represented thousands of hours of engineering refinement, incorporating lessons learned from extensive field testing and feedback from tank crews who had operated earlier communication systems. The final product weighed 35 pounds, occupied less than cubic feet of space, and provided communication capabilities that rivaled systems 10 times larger and heavier. February 28, 1944 found Hauptmann Friedrich Fritz Wagner crouched in the commander's cupola of his Panzer IV, scanning the Norman countryside through Zeiss binoculars while struggling to make sense of the tactical situation developing around his position. What Wagner could not have known, could never have imagined, was that American Sherman tanks positioned 3 kilometers to his east were coordinating a complex pincer movement using radio technology so advanced that German intelligence agencies had not even theorized its existence. Frequency-modulated signals passing between American armored units remained completely invisible to German intercept stations, creating a communications blackout that left Wehrmacht forces fighting blind against an increasingly sophisticated enemy. Wagner's radio operator Jeffreiter Klaus Müller hunched over their FUG-5 radio set, desperately attempting to establish contact with neighboring units through the crackling static that plagued all German amplitude-modulated communications. The antiquated system, developed in the mid-1930s, suffered from constant interference, limited range, and vulnerability to enemy jamming. That made tactical coordination a nightmare. American direction-finding stations easily triangulated German radio transmissions, providing Allied artillery units with precise targeting information that devastated Wehrmacht formations. The German High Command remained completely unaware of the technological revolution occurring within American armored units. Intelligence reports filed by the Oberkommando der Wehrmacht consistently attributed American tactical superiority to numerical advantages and superior logistic support, while completely missing the communication revolution that enabled unprecedented coordination between individual tanks, infantry units, and supporting artillery. Captured German documents, discovered in archives after the war, reveal a military leadership that never grasped the fundamental importance of advanced battlefield communications. Oberst Heinrich Heinz Guderian III, nephew of the famous Panzer General and commander of the 501st Heavy Panzer Battalion, experienced the frustration firsthand during the fighting around Cannes. His Tiger tanks, individually superior to any Allied armor, found themselves consistently outmaneuvered by Sherman formations that seemed to anticipate German movements with supernatural prescience. What Guderian interpreted as exceptional American tactical instincts was actually the result of real-time intelligence sharing enabled by the SCR 506 radio network. Technical intelligence gathering proved equally challenging for German forces. The frequency-modulated signals used by American tanks operated outside the frequency ranges monitored by German intercept stations, rendering enemy communications effectively invisible to Wehrmacht intelligence officers. German direction-finding equipment, calibrated for amplitude-modulated signals, could not detect or triangulate American tank positions based on their radio transmissions. This communication invisibility provided American armored units with unprecedented tactical flexibility. The psychological impact on German tank crews proved devastating. Veterans of the Eastern Front, accustomed to fighting against Soviet forces equipped with minimal radio communications, found themselves facing an enemy that seemed to possess perfect battlefield awareness. American tanks appeared at unexpected locations, concentrated firepower with devastating timing, and disappeared before German forces could respond effectively. Wehrmacht's rigid command structure, dependent on written orders and telephone communications, proved completely inadequate against an enemy capable of real-time tactical adaptation. Lieutenant Johann Hans Richter, a Tiger tank commander with the 2nd SS Panzer Division, documented his experiences in letters to his wife that were later captured by Allied intelligence. As referenced in declassified OSS files from the National Archives, Richter described fighting against American armor as boxing against an opponent who can see our punches before we throw them. His vivid descriptions capture the frustration of German tankers, who found themselves consistently outmaneuvered by technically inferior but better coordinated enemy forces. Strategic implications extended far beyond individual tank engagements. German operational planning based on assumptions about Allied communication capabilities derived from experiences fighting British and Soviet forces proved completely inadequate against American armored formations that could coordinate across vast distances with unprecedented precision. Wehrmacht intelligence estimates consistently underestimated American tactical flexibility, leading to strategic decisions that played directly into Allied strengths, while ignoring German advantages in individual tank performance and crew training. March 19, 1944 witnessed the most sophisticated display of armored coordination in military history as elements of the 4th Armored Division executed Operation Cobra. The breakout from the Normandy beachhead, Staff Sergeant Michael Malley, commanding a Sherman tank designated Fury's Revenge, received simultaneous radio transmissions from battalion headquarters, neighboring tank platoons, and forward artillery observers while maintaining perfect situational awareness across a battlefield spanning 15 square miles. The SCR 506 radio network had transformed individual tanks into nodes in a vast information web that processed tactical intelligence with computer-like efficiency decades before digital battlefield management systems would be invented. The communication architecture represented a paradigm shift in military thinking. Unlike traditional hierarchical command structures that filtered information through multiple layers of command, the American FM radio network enabled direct communication between units at all levels. Tank commanders could coordinate directly with infantry platoons. Artillery observers could communicate with individual tanks, and reconnaissance units could broadcast real-time intelligence to every friendly unit within range. This horizontal information sharing created tactical flexibility that German forces, bound by rigid command protocols, could not match or counter. Captain Robert Bob Patterson, the signals officer for Combat Command Alpha, monitored the radio traffic from his command half-track, while documenting communication patterns that would later influence military doctrine for decades, according to his after-action reports. Preserved in the Patton Museum archives, American tank formations demonstrated the ability to execute complex tactical maneuvers. That would have been impossible with conventional communication systems. Units separated by miles of terrain could coordinate flanking movements with split-second timing, concentrate firepower on critical targets, and redistribute based on real-time battlefield developments. The technical specifications of the SCR 506 system enabled this tactical revolution. The radio operated in the 30 to 39 MHz frequency band, providing 18 distinct channels that allowed simultaneous communication between multiple unit levels. Tank commanders could monitor battalion command nets while maintaining contact with their individual crews, creating information redundancy that ensured critical communications reached their intended recipients. Even under intense combat conditions, German intercept stations monitoring American radio traffic through conventional amplitude modulation detection equipment reported mysterious gaps in enemy communications that they attributed to sophisticated code systems or communication discipline. Wehrmacht intelligence officers never discovered that American tanks were communicating continuously using frequency-modulated signals that remained completely invisible to German detection equipment. This intelligence blindness prevented German forces from developing effective countermeasures against American communication advantages. The operational impact proved decisive during critical engagements. At the Battle of Ercourt in September 1944, American tank formations equipped with SCR 506 radios defeated numerically superior German panzer units through superior coordination rather than individual tank performance. Major General John Juckwood, commanding the 4th Armored Division, later credited the communication superiority with enabling tactical victories that would have been impossible using conventional radio equipment. Technical Sergeant William Bill Rodriguez, radio maintenance specialist with the 3rd Armored Division, documented the reliability advantages of frequency-modulated equipment in his detailed maintenance logs. Unlike German amplitude-modulated radios that required constant tuning and adjustment, the SCR 506 systems maintained clear communication quality under extreme conditions. Tank crews could focus on fighting rather than wrestling with temperamental communication equipment, providing a subtle but significant combat advantage. The network effects multiplied as more units received the advanced radio equipment. By summer 1944, entire armored divisions operated as integrated information-sharing networks that processed battlefield intelligence with unprecedented speed and accuracy. Individual tank commanders possessed situational awareness that rivaled division-level staffs using conventional communication systems, enabling tactical initiative at the lowest command levels and creating chaos for German forces. Accustomed to fighting predictable, hierarchically controlled opponents, April 6, 1944 transformed the relationship between predator and prey as American tank hunters began systematically stalking German armor using communication advantages that rendered enemy forces tactically blind. Lieutenant Colonel James Jimmy Hawthorne, commanding the 7th Armored Regiment, coordinated a tank versus tank engagement near Villers-Bocage using radio communications that allowed his Sherman crews to operate like a pack of wolves hunting isolated prey. The German panzer crews, individually superior in firepower and armor protection, found themselves facing an enemy that seemed to possess supernatural coordination abilities and perfect battlefield awareness. The tactical revolution centered on information sharing that occurred at the speed of radio waves, rather than the speed of human messengers or telephone lines. Tank commanders could instantly alert neighboring units to enemy positions, coordinate simultaneous attacks from multiple directions, and call for immediate support when outgunned by superior German armor. Staff Sergeant David "Dave" Miller, commanding a Sherman-designated American Pride, demonstrated these capabilities during a fierce engagement with a Tiger, a tank that had been terrorizing Allied supply lines for 3 weeks. Miller's crew spotted the massive German tank from a concealed position at dawn, immediately broadcasting its location to every American unit within a 20-mile radius. Within minutes, 3 additional Sherman tanks had maneuvered 2 flanking positions, while a 4th provided overwatch from a distant ridge. The Tiger's crew, operating with the limited situational awareness provided by their Fug 5 radio system, never detected the coordinated American response until shells began impacting their position from multiple directions. Simultaneously, the German tankers fought with desperate courage, but found themselves overwhelmed by an enemy that seemed to anticipate their every tactical decision. Hauptmann Werner Wolf Steinberg, the Tiger's commander, attempted to withdraw to a more defensible position, only to discover that American tanks had already blocked his escape routes. The sophisticated communication network had enabled real-time tactical coordination that trapped individual German tanks in carefully orchestrated killing zones. According to declassified Army Air Force's intelligence reports, American tank crews began developing hunter-killer tactics that leveraged their communication advantages to devastating effect. Sherman tanks, individually outmatched by German Panthers and Tigers, could coordinate attacks that neutralized enemy armor through superior tactical positioning rather than superior firepower. The psychological impact on German tankers proved enormous, as they found themselves consistently outmaneuvered by supposedly inferior American equipment. The frequency-modulated radio signals provided American forces with additional advantages beyond simple communication clarity. The SCR 506 system included provisions for encrypted voice transmission, using simple code words that changed daily, ensuring that even intercepted American communications provided no useful intelligence to German forces. Meanwhile, German amplitude-modulated transmissions remained vulnerable to interception and direction finding, allowing American intelligence units to track enemy movements with remarkable precision. Sergeant First Class Anthony Tony Caruso, a radio operator with extensive experience fighting German armor, developed innovative communication protocols that maximized the tactical advantages of frequency-modulated radio. Techniques later incorporated into official training manuals emphasized real-time information sharing that enabled small unit leaders to make tactical decisions based on complete battlefield awareness rather than limited local knowledge. The cumulative effect transformed American armored units from collections of individual tanks into integrated weapon systems that operated with hive-mind coordination. German panzer crews trained to fight as individual hunters seeking isolated prey found themselves facing an enemy that operated as a coordinated pack with perfect internal communication. The Wehrmacht's tactical doctrine, based on individual tank superiority and aggressive, independent action, proved completely inadequate against American formations that leveraged technological advantages to overcome individual equipment limitations. The battle statistics reflected this tactical revolution. American tank losses decreased dramatically as crews learned to coordinate mutual support using their advanced communication equipment, while German armor found itself increasingly isolated and vulnerable to coordinated attacks that exploited the mobility and numerical advantages of Allied forces. May 14, 1944 marked a critical turning point in the electronic intelligence war as German cryptographers at the Wehrmacht's Signal Intelligence Service in Berlin struggled to decode American tank communications that seemed to have vanished into electronic silence. Worst Hermann Hans Krieger, the service's leading radio intercept specialist, studied hundreds of hours of recorded Allied transmissions without discovering the frequency-modulated signals that were revolutionizing battlefield communications, just beyond the detection range of his sophisticated monitoring equipment. The German intelligence apparatus, among the world's most advanced, remained completely blind to the technological revolution occurring within American armored formations. The irony proved particularly bitter for German intelligence officers, who had spent years developing elaborate direction-finding networks designed to track enemy radio communications. Intercept stations positioned throughout occupied Europe could precisely triangulate Allied amplitude-modulated transmissions and provide targeting information for German artillery and airstrikes. However, the frequency-modulated signals used by American tanks operated outside their detection parameters, rendering the entire German signals intelligence infrastructure useless against the most tactically important Allied communications. Major Wilhelm Willy Hoffmann, commanding the 7th Radio Intercept Company, documented his frustration in classified reports that were discovered in captured German archives after the war. According to these documents, housed in the National Archives, German intercept operators frequently reported mysterious gaps in American radio traffic that coincided with coordinated enemy attacks. Hoffman's analysts theorized that American forces had developed sophisticated burst transmission systems or elaborate code schemes, never suspecting that Allied tanks were communicating continuously using undetectable frequency-modulated signals. The technological blindness extended to the highest levels of German military intelligence. The Oberkommando der Wehrmacht's weekly intelligence summaries, based on intercepted communications and prisoner interrogations, consistently underestimated American tactical coordination capabilities while attributing Allied battlefield success to numerical superiority and overwhelming logistics support. German intelligence analysts never grasped that American armored units possessed communication technologies that fundamentally altered the tactical balance of armored warfare. Captain Heinrich Henry Müller, former civilian radio engineer serving with Army Group West's intelligence section, came closest to discovering the American communications secret during the fighting in Normandy. His technical analysis of captured American radio equipment revealed frequency ranges that German intercept stations did not monitor, but his reports disappeared into the Wehrmacht's bureaucratic maze without reaching decision-makers who might have ordered countermeasures or equipment modifications. The strategic implications proved devastating for German defensive planning. Wehrmacht operational intelligence based on intercepted radio traffic and communication pattern analysis provided German commanders with detailed knowledge of British and Soviet tactical procedures, while leaving them completely ignorant of American armored coordination capabilities. German defensive positions, designed to counter Allied tactics derived from electronic intelligence, proved completely inadequate against American formations that operated using coordination methods the Germans had never encountered. Technical Sergeant Klaus Karl Weber, radio intercept specialist with extensive experience monitoring Allied communications, later described his wartime service in memoirs published in 1967. Weber's account reveals the growing frustration among German intelligence operators who found themselves fighting an increasingly sophisticated enemy, while their own technical capabilities remained frozen in 1930s technology. The communication intelligence war reflected broader technological trends that would determine the conflict's outcome. While German industry focused on producing incremental improvements to existing weapon systems, American research and development programs pursued revolutionary technologies that provided qualitative advantages independent of numerical superiority. The SCR-506 radio system exemplified this approach, offering capabilities that transformed American tactical doctrine while remaining completely invisible to German countermeasures. The electronic blindness created by frequency-modulated communications contributed to German strategic miscalculations that would prove decisive during the war's final phases. Wehrmacht intelligence estimates, based on incomplete information derived from obsolete intercept technologies, provided German planners with fundamentally flawed assessments of Allied capabilities and intentions, leading to strategic decisions that accelerated the Third Reich's ultimate defeat. June 21, 1944, dawned with the thunderous roar of Allied artillery as Operation Progression commenced along the Eastern Front. While simultaneously, American armored spearheads equipped with SCR-506 radios began their devastating breakout from the Normandy beachhead. Colonel William Wild Bill Morrison, commanding Combat Command, Baker, of the 2nd Armored Division, coordinated a multi-pronged assault using communication technologies that allowed real-time tactical adjustments impossible with conventional radio equipment. German defenders, commanded by General Major Kurt Ironcross von Seckendorf, found themselves facing an enemy that seemed to possess perfect battlefield omniscience and supernatural coordination abilities. The tactical situation demonstrated the decisive impact of advanced communications on modern warfare. American tank columns, guided by real-time intelligence from reconnaissance units and artillery observers, navigated through German defensive positions with surgical precision, while maintaining perfect coordination across vast distances. Individual Sherman crews received continuous updates on enemy positions, friendly unit locations, and tactical developments that allowed them to exploit momentary advantages with devastating effect. Von Seckendorf, a veteran panzer commander with extensive Eastern Front experience, discovered that his conventional defensive tactics proved completely ineffective against American formations that operated as integrated information networks rather than collections of individual tanks. His attempts to concentrate defensive firepower against isolated American spearheads failed repeatedly as Allied commanders received immediate warning of German troop movements and adjusted their tactics in real time. The communication superiority enabled American forces to execute complex tactical maneuvers that would have been impossible using conventional radio equipment. Technical Sergeant Robert Robbie O'Connor, commanding a Sherman in the lead element of the American advance, maintained simultaneous contact with battalion headquarters, adjacent tank platoons, supporting artillery units, and forward air controllers, while coordinating a river crossing under intense German defensive fire. The frequency-modulated signals remained crystal clear, despite electronic interference from German jamming attempts and the electromagnetic chaos of modern battlefield conditions. German defensive coordination, dependent on telephone lines and motorcycle messengers, proved completely inadequate against an enemy capable of real-time tactical adaptation. Lieutenant Colonel Hans Heinrich Richter, commanding the defending Panzer Regiment, watched helplessly as American tank formations exploited gaps in his defensive line before he could redistribute his forces to counter their movements. The Wehrmacht's rigid command structure, designed for set-piece battles with predictable enemy behavior, collapsed when confronted with American tactical flexibility enabled by superior communications. The psychological impact on German defenders proved equally devastating. Soldiers who had successfully defended against British and Soviet attacks using conventional tactics found themselves completely overwhelmed by American formations that seemed to anticipate their every move, according to prisoner interrogation reports preserved in Allied intelligence archives. Captured German officers consistently described fighting American armor as boxing against an invisible opponent who knows all our moves in advance. Staff Sergeant Michael Mickey Kowalski, a radio operator with the 1st Armored Division, documented the communication patterns that enabled American tactical success in detailed after-action reports. His observations, later incorporated into post-war tactical doctrine, emphasized the importance of horizontal information sharing that allowed small unit leaders to coordinate complex maneuvers without waiting for orders from higher headquarters. This decentralized decision-making process, enabled by reliable communications, provided American forces with crucial tactical advantages over German opponents bound by hierarchical command structures. The strategic implications extended beyond individual battles. German high command intelligence estimates, based on intercepted communications and prisoner interrogations, consistently underestimated American coordination capabilities while overestimating the effectiveness of defensive measures designed to counter conventional Allied tactics. This intelligence failure contributed to strategic miscalculations that placed German forces in untenable positions throughout the European theater. The breakout from Normandy demonstrated the revolutionary impact of advanced battlefield communications on modern warfare, establishing communication superiority as a decisive factor equal in importance to air superiority. Logistics support and individual weapon system performance. September 8, 1944 witnessed the final vindication of American communication superiority as the Third Army's armored spearheads, guided by SCR 506 radio networks, raced across the German frontier while Wehrmacht forces collapsed in confusion and tactical paralysis. General George Old Blood and Guts Patton III, commanding the most rapidly advancing Allied army in European history, later credited his communication superiority with enabling tactical victories that traditional military doctrine considered impossible. The frequency-modulated radios that German intelligence agencies never detected had become the invisible foundation of Allied victory, transforming individual tanks into nodes in an information network that processed battlefield intelligence with unprecedented speed and precision. The final campaigns demonstrated communication technology's decisive role in modern warfare. American armored formations, operating as integrated information-sharing networks, consistently outmaneuvered German forces that retained superior individual tank performance and tactical expertise. Lieutenant Colonel James Jimmy Patterson, commanding the 4th Tank Battalion. The race to the Rhine coordinated complex river crossing operations using radio communications that allowed simultaneous coordination between engineers, artillery, air support, and armored spearheads across a 50-mile front. German resistance, hampered by communication systems that belonged to an earlier era of warfare, crumbled under the pressure of American tactical flexibility enabled by technological superiority. General Major Friedrich Fritz von Manstein, commanding the defense of the Siegfried Line, attempted to coordinate defensive operations using telephone networks and motorcycle messengers, while facing an enemy that communicated at the speed of light across vast distances. His defensive positions, designed to counter conventional Allied tactics, proved completely inadequate against American formations that operated with real-time battlefield awareness. The statistical evidence overwhelmingly supported the decisive impact of communication superiority. American tank losses decreased dramatically as crews learned to leverage their radio advantages, while German armor found itself increasingly isolated and vulnerable to coordinated attacks that exploited technological rather than numerical advantages. Staff Sergeant William Billy Thompson, a Sherman commander with extensive combat experience, reported tank survival rates that improved by over 60% once crews mastered advanced communication procedures. The post-war analysis, conducted by military historians and intelligence agencies, revealed the full scope of German technological blindness regarding Allied communication capabilities. Captured Wehrmacht documents, housed in various national archives, demonstrate that German intelligence never discovered the frequency-modulated radio systems that revolutionized American tactical coordination. This intelligence failure contributed directly to strategic miscalculations that accelerated Nazi Germany's military collapse. The human cost of technological inferiority proved staggering for German forces. Panzer crews, individually superior in training and equipment, found themselves consistently outmaneuvered by American formations that possessed perfect situational awareness and unprecedented coordination capabilities. Obergefreiter Klaus Karl Steinberg, captured during the Battle of the Bulge, described fighting American armor as battling ghosts who appear everywhere at once while we stumble blind through the darkness. The SCR 506 radio system represented more than technological advancement. It embodied a fundamental shift in military thinking that recognized information superiority as equally important as firepower, armor protection, and numerical strength. American tactical doctrine evolved through combat experience with advanced communications, created templates for future military operations that would dominate battlefield thinking for decades after the war's conclusion. As documented in the official Army historical series, the frequency-modulated radio revolution transformed American armored forces from collections of individual tanks into integrated weapon systems capable of tactical coordination that German forces never understood or effectively countered. The silent electromagnetic signals that connected Sherman tanks across European battlefields had become victory's invisible partner, proving that in modern warfare, the side with superior information processing capabilities possessed decisive advantages that traditional military measurements could not detect or quantify. The German troops never knew what hit them literally. In the electromagnetic spectrum they couldn't monitor, American tankers had been talking, coordinating, and winning a war that was decided as much by invisible radio waves as by armor-piercing shells.